All right, as I promised, we are going to pick up with this video right where the previous one left off. So if you haven't seen the standard access list video, jump back and check out that one first because extended is a little more complex. We're going to pick up with the second set of scenarios, scenario 3 and 4, using extended access lists to permit or deny IP and TCP access and also explaining many of the other things that they're able to do. So let's get going. I'd like to approach the extended access list the same way that I approach the standard, in that before we jump into this scenario 3 and 4 on the whiteboard here, I'd like to talk about the syntax in general, and then we'll hit the scenarios directly. Now, I do have to warn you before we get going with the extended access list that some people consider the extended access list the most difficult concept in CCNA. I don't think it's that bad, but I do think that the syntax can be a little frightening the first couple times through it. The first thing that we need to do is break down the extended access list into its major pieces. The command structure is just like the other one. We type in access list to start off and an identifier or a number from 100 to 199, just like we saw in the previous video. Now, that identifier tells the router you're creating an extended access list. From there, you have your permit or deny, just like the standard, and then we see our differences. We get to choose what protocol we would like to permit or deny. Examples of that might be like TCP or UDP, or there's some other ones we'll talk about in just a moment. We then type in our source information. And then we follow that up. I'm going off my little white pad here. We follow that up with our destination information. So I might say something like access list 100. Permit the TCP protocol from this IP address to that IP address. Not too bad when you think about it that way. But there are more options that you'll have to weed through, like port numbers and stuff like that, which we will get into as we get into scenario 4 right there. So what I'd like to do is just walk through a syntax of a couple access list commands, and then we'll look at the scenario specifically. To demo this, I'd like to jump onto router 3. It's a good place to just try some syntax. On router 3, I'll get into global config mode and do access list and a question mark. There's our options as we saw before. Extended access list is any number from 100 to 199. I'll pick 150, right in the middle. Comes up and says, do you want to deny dynamic? That's some of the other options, and we're not going to talk about every option with these extended access lists. We'll say deny, permit, or remark. So we'll say access list 150, let's do deny. Comes up. Now we're given our protocol options. If you're wanting the OSI model, these are all the protocols at layer 4 of the OSI model. TCP, UDP, you see those at the bottom. But we also see ICMP, ESP, that's used for VPN connections. There's many different options in here, but let me just focus in on what we need at the CCNA level. There's 4 different protocols: IP, TCP, UDP, and ICMP. Okay. Now TCP and UDP we already know about. Those protocols are used, as a reliable connection or an unreliable connection. Things like web browsing, FTP sessions, telnet sessions, SSH. There's all, email, SMTP. They all use reliable connections. Most of our applications do. Things like voice over IP, video streaming, online games, instant messengers. Those all use UDP-based communication because they're all unreliable. So depending on what kind of applications we're using, we could choose those protocols. But we also see ICMP. ICMP is the Internet Control Message Protocol. It's used for a lot of things. But the primary application you want to remember for it, for the CCNA level, is ping. Anytime you ping something, it is using the ICMP protocol. Technically, a ping is an echo and an echo reply. Think about a submarine. Underneath you're going boom, sending out sonar, and you expect to hear that back to see where things are. In the same sense, the ping command sends out a message known as an ICMP echo, and the device that receives it sends back an echo reply. That's technically how ping works. But ICMP is used for a lot of different things. Ping is, I would guess, the most famous of them all. Last but not least is the IP protocol. That one is used, and you can see that right here in this list. Oops, right here. To encompass everything. For example, if I were to say deny TCP, then I'd only be denying TCP applications for something. Like maybe I wanted to deny one host from accessing another completely. If I deny TCP, that would just deny TCP applications, but they'd still be able to use UDP or ICMP, things like that. If I just denied one of the other ones, you'd miss them all. IP is everything. As you can see in that description right there, it says any internet protocol is encompassed in that. So if I said deny IP, that means TCP, UDP, all these, everything is denied. So let me first show you an example of that one. I'll say deny IP, and it says what source address would you like to deny? I'll say 192.168.10.50 just to pick on host A. We will deny that address. It says what wildcard mask would you like? Well, since it's just a single host, a specific wildcard mask will work. Now I hit the question mark and it says, okay, what destination do you want to deny? So I'll say the destination will be, just for this example, 192.168.3.50. Followed up with the wildcard mask 0.0.0.0. Question mark. And now it's giving me some options. Do you want to set DSCP? Do you want to check non-initial fragments? Do you want to log anytime this happens? Is there specific time ranges? All these options are part of the CCNP track. So we're not going to do that. You can see very end is return. And I'll tell you, most of these options are rarely used. So I'm going to hit enter, and I've now created my first extended access list. What it does, access list 150 denies this source from accessing this destination using any protocol in the TCP/IP protocol suite. Going back to that syntax I wrote up there, deny protocol, source, and destination. So I know what you're thinking. It's not too bad, right? Not too bad at all. It's not, if you look at it that way. But it is pretty long. And also, realize that you could combine things up. If we were going back here, access 150, deny this source, I could do space question mark, and I'll say, instead of putting the IP address like I did up here, I could also put, host 192.168.3.50, and that would do exactly the same thing. There's different ways to write it. This is using a wildcard mask. This is using the host keyword, but functionally that and that are the same thing. The IP protocol is I would say the easiest one to permit or deny, because it's just saying from this IP address to that IP address. Now let's look at, we'll say TCP. Access list 150 deny. Let's do instead of IP, and remember this is just, I'm showing the syntax. I'm not looking for any specific mission here. We'll say I'm going to deny the TCP protocol from, and we can see that same host, 192.168.10.50, space question mark. It says what wildcard bits? 0000. So specifically that host, and now we'll start seeing a little bit of difference. With the TCP protocol, it says, okay, well, TCP can have port numbers, meaning you might not want to deny the whole TCP protocol. You may just want to deny a certain port. Now, here's the catch. If I go in here and type in deny TCP 192.168.10.50 without wildcard mask, and I say, I only want to deny that guy from surfing the web, I could put equal to, you can see EQ, match only a given port number, space question mark, and then it says, okay, well, what port do you want? And it gives a lot of the common ports that people will use in here. Or they can say, right up top, you can just type in the number. So you might say, well, I want to deny that host from using port 80, which is HTTP, web access, surfing the web. Now, there's the problem. When we type that in, we are denying this source and this source port number. It's time for a little review. Remember, whenever we have a computer that is surfing the internet, you are going to, we'll say, google.com. I'll just put g.com. When this computer goes out, it's going to be going to the destination port number 80, which is how google.com knows that you're accessing the web services on there, not email or not anything like that. Destination port number. But the computer, when you go and surf the website, generates a source port number at random, meaning Firefox or Internet Explorer or Safari, whatever web browser you're using, will automatically be assigned a port number. We'll say, and it's going to be greater than 1024, we'll say 3192. Okay? So when you transmit to google.com, you'll come from a source of 3192 to a destination of 80, and that's how Google knows to send you to the web services. And when it sends that web page back to you, it will send to a destination of 3192 from a source of 80, and that's how your computer knows to give it to the Internet Explorer window or Firefox window, because that window has been assigned for a time that specific port number. Now, rarely, if ever, will you ever know what source port number a computer is going to be generating, because it's at random. So when we come back here to the syntax, this is where it's very easy to get tripped up, because you type in a source of this and we say equal to 80, but we're denying that host from using the source port of 80. Remember, this host is the one surfing the web. It's never going to come from a source port of 80. It's only going to be going to a destination port of 80. So how do we fix that? Well, you can see right here, I typed in deny TCP from this source IP address. Now it's giving me the option to type in port numbers, but I'm not going to take that option. I'm not going to put in a port number at this point. I'm just going to say the whole host. Deny, any source port number from accessing, and now we can move on to the destination. If I'm talking about the internet, I'll say any. Deny this source from accessing any destination using, and now I hit the question mark, and the port numbers are still there. You see that? Equal to a port number. Not equal to a port number. Less than a port number. All these are port number options, but now, since we're typing it after the destination, we're talking about the destination port number. So the correct way to type in, if I was denying that host from surfing the web, I put equal to 80. Deny this protocol from this source host number to this destination on the destination port number 80. Phew! Not quite as easy as the IP protocol, but that's how that's how you can write an extended access list. So, with that in mind, what I would like to do is walk through both of these scenarios one by one and implement extended access lists in the best possible way. So scenario 3, use an extended access list to prevent host A from accessing the R2 WAN link. Now when I see that, my initial thought goes to, well, does that mean this IP address, or does it mean the WAN link? Well, I would say it means the link, meaning prevent host A from accessing this IP address or that IP address. Okay. So I'm going to, let's just clear all this off. First thing I'm going to do is go over to router 3, and I'm going to remove any access list that's on there, because I don't want any of those causing any confusion or conflict with what we're about to do. We've got access list 25 from the last video and 150. So I'll just do no access list 25, wham, it's gone. No access list 150, wham, it's gone. So with that in place, we now have no access lists created on this router. It's empty. And I'm going to hop over to router 2 to do this demonstration, to create this access list. Now, I'll talk about the placement of the extended access list in a moment, but let's first create it. It says prevent host A from accessing the R2 WAN link. Host A is 192.168.10.50. The R2 WAN link is this subnet. So notice it didn't specify any protocol. It didn't specify anything. So I'm assuming all access from that subnet. So I'm going to jump back up here, router 2, and I'm going to go into global config mode and create an access list. We'll do access list. Let's start at the first one of the extended range, access list 100. I'll say I want to deny the IP protocol, because in my scenario it says accessing the R2 WAN link, the whole WAN link. It doesn't matter what protocol. So I'm going to say complete access, no matter what protocol they're using, is going to be denied. So I'm saying deny IP. From the source, we'll say from the source host 192.168.10.50. Now you'll notice that I'm using the question mark the entire way through this access list. This is normal. Most people do use the question mark. And when you're on the CCNA exam, if certification is your focus, you will be able to use the question mark yourself in configuring this. So you can safely get used to it. So I'm going to say deny that host, 10.50. Then I'll hit the question mark. And it's saying from what destination? Well, let's take a look. It says the R2 WAN link. So I have two options here. I can either create one line and deny that host from that whole subnet, the 2.0 subnet, or I can put two lines in an access list and say deny from that host and deny from that host, and put it in two lines. Now, the best bet whenever you're configuring access lists is to do it in as few lines as possible. The reason why is because the more lines you add, the more processing the router has to do. It's kind of like having a large routing table, and it'll slow the router down. So let's do it efficiently. Let's do it in one line. I'm going to say deny that host from accessing the destination address 192.168.2.0 with a wildcard mask 0.0.0.255, which says specifically 192.168.2. Deny him from accessing anything that has specifically 192.168.2, and I don't care what comes after that. So anything that starts with this, he will be denied from. This last octet doesn't matter. So do a question mark, and it says, here's all your logging, time range. We're not going to use any of those options. We're just going to hit enter. Okay. Now, I have to remind you the same rules apply for extended access lists as they do for standard access lists. If you have an access list with all denies, it will deny everything because at the bottom of this extended access list is an invisible implicit deny. So what I would say is after we're done doing what the scenario asked for, which is denying that host from accessing that WAN link, then we should be able to go in and permit everything else. Now you remember from our extended access list that we typed in permit any, but it won't take that with an extended. We have to type in permit and then what protocol? Well, for permitting everything, it's going to be the IP protocol, and we'll put from any source to any destination. That is how you do a permit everything using an extended access list. I'm going to type in show IP access list. By the way, show IP access list and show access list do the exact same thing. So sometimes I'll use one or the other, whatever on my mind at the time. And I can see there is my deny from that host to that subnet, and then I'm permitting everything else. Good. So we've got the access list written that will do what it needs to do, but now we have to apply it. Think about it. If you were looking for efficiency and for completing the task, you want to make sure that you deny that host, where would you apply that access list? Option A. We can apply that access list as the host comes in. Remember, this is on a VLAN, so it's going to be coming in right here on its default gateway. That's option A, that we could apply it. We could apply it in the direction inbound. As that host comes in, it's going to ask, are you that source? Are you accessing that destination? If so, you're denied. That's our first option. Second option is we could apply it outbound right here. And as that host goes out, the router 2 would ask, are you the source? Are you trying to access that destination? If so, you are denied. So we'll call that option B. Option C, we could apply it inbound right here. So as it gets to router 3, it will say, are you that host? Are you accessing the WAN link? If so, you are denied. You are on a certification exam. D is none of the above. What letter do you pick? Remember, we're after efficiency and we're after accomplishing the objective. The correct answer is A. B would accomplish the objective. It would work if I put it at B, but it would cause unnecessary processing. Meaning, as host A comes into fast Ethernet 0/0, it will be able to check and say, are you this host, 10.50? The host will answer, yes, I am. The router will say, are you trying to access this destination, the 2.0 subnet? And the host will answer, yes, I am. So before the router even has to allow it into itself, into that default gateway, it will say, well, since those two criteria are true, you are denied. Now, if we applied it outbound, the second option, option B, on router 2, host A would get into the router, meaning it would come in, the router would say, are you this host, and are you going to this destination? The host would say yes. It would say, okay, great, I don't have an access list here, so let me look up in the routing table. Okay, it looks like you need to go out serial 0/1/0, so let's go ahead and route you over. So the packet would be moved from the Ethernet interface to the WAN interface, but before it's sent, the router would say, oh, I see there's an access list outbound on that interface. Let's check you. Oh, you don't match, you will be denied and dropped. The problem is that squiggly line right there. It had to process that in order to make that determination. So now we come to the next best practice rule of Cisco. Standard access lists should be applied closest to their destination. Because in a standard access list, remember we're talking scenario 1 and 2 there, you can't say what they're denied from. So by putting it too close, you may deny them from too much. So you can think of it as standard, I'll just put stand equals destination. Extended, the best practice is to apply them as close as possible to the source. Because you can, in an extended access list, say what they are denied from. So if we can get, if we could, if it were possible to apply it on the switch, by golly, do it there, if you can, because as that host is coming into that interface, we can say, are you this host? Are you trying to go there? If you are, you're denied. You've prevented it from even being processed by the router. But applying access lists on switches is part of CCNP track. We're not going to talk about that here. But so the closest source that we have is our router and its default gateway. So let's go back on to router 2. I'll do a show IP interface brief just to verify. There is fast Ethernet 0/0.1. And you know what? Before I apply this access list, I want to make sure that host A can indeed access that WAN link. Let's bring up our connection to host A. Whoa, he's a little off there. I'm going to ping 192.168.2.1. It is replying, and 2.2. It is replying. So it is able to ping 2.1 and 2.2. And why not? Let's do this. I'll also ping 3.1 because I want, 3.1. Because I want to make sure enough, we can get to 3.1, which is on the other end of the WAN connection. So what I'm going to do is go onto that router under the fast Ethernet 0/0.10, which is host A's default gateway, and same command as before, IP access group 100, the name of our access list or number, and what direction? In. Now again, with extended access lists, it's especially as important to hold out your arms and really determine which direction. It's as that source comes in that fast Ethernet 0/0.10 that it's going to be processed. If it were going out, if I applied it in the outbound direction, the source would be seen as if it were leaving that interface, which is not true. That would probably mean it's coming from somewhere else on the network than that interface. So we've applied it in, right? Let's do a show access list 100. Looks like it's there. No packet hits yet. Let's jump back over to the host. All right, let's do a clear screen, and we'll do ping 192.168.2.1. Look at that. Destination net unreachable. Ping 192.168.2.2. Destination net unreachable. Reply from our router, 10.1. You are being denied. Let's jump on over to our router and hit that up arrow. And look at that. We are getting matches now on that deny to 192.168.2.0. Now I've got a question for you. What do you think? Will host A, we just verified host A cannot access 2.1. It cannot access 2.2. Will host A be able to ping 3.1 or this IP address on router 3? Think about that. What do you think? Jeopardy music enters here. The answer to that question is yes. Now, wait a sec, you might be thinking. He's using the WAN link to get there. That's true. He is using the WAN link to get there, but the WAN link is never in a destination field of the IP header. And this is why it's so important to understand how networks communicate before you get to this point, is because host A, when it's engineering the packet, it will have some data. It will put its, protocol, which is TCP or UDP or ICMP, source and destination port number, source and destination IP address. If I were to ping 192.168.3.1, the source IP is 10.50, which is host A. The destination IP is 3.1. So when it comes into router 1 and it looks at the access list, it's going to say, okay, are you that source, 10.50? And it says, yes, I am. And it says, are you trying to go to 2.0, the 2.0 subnet? And the host will say, no, I'm not. I'm trying to go to 3.1. And so the router will say, okay, well, then I guess that access list does not match. I will go ahead and allow you through. So let's test it just to be sure. I'm going to bring up that terror term, and you can see as of right now we've got the deny, and we've got some permit traffic that has made its way through since I've been talking. Just hit it again. Something's going through, so I'm not too sure what that is, but we'll test it. I'll go to my host right here. You can see 2.1 and 2.2 are denied, and I'll just hit the up arrow and do 3.1. 3.1. There we go. And that is still going through successfully. We are getting replies coming back. And if I go back over to my show command, I can see that the permits have been increasing because they are being allowed through because of that reason I just mentioned. So, scenario 3. We can put a red check on that guy. We are good. Last but not least, we'll hit scenario 4, and then I'll show you some of the tips and tactics and tricks of access lists. Scenario 4 says, use an extended access list to prevent host A from accessing the CBT Nuggets homepage. Now, why you would ever want to do anything like that is beyond me. But we'll go ahead and do it for this example, then we'll immediately remove the access list and forever revoke any such policy. So we have to prevent host A from the CBT Nuggets homepage. So immediately that triggers in my mind, we're talking homepage. We're talking web access, somebody being able to access a web server that presents a homepage. So what I'm going to say in that case is that we need to deny, if we're talking in technical terms, host A from using TCP port 80, destination port, to access the CBT Nuggets homepage. So now we come to a question, well, what's the IP address of CBT Nuggets web server? Well, let's go to our command line, and we'll do a ping www.cbtnuggets.com. All right. CBT Nuggets is blocking ping traffic, as many websites do, because that you can actually attack websites that allow ICMP. But that is the IP address that represents the homepage. So with that IP address in our knowledge, let's go ahead and I'll just copy that to my clipboard and stick a little text box up here. Just pick a font. There we go. Paste. Not that font. How about that one? It's a little better. So we'll do 128.242.116.211. I think I can read that. I can't read that. I'm going to make that a little larger. There we go. 128.242.116.211. All right, good. So that's the IP address that we're going to be denying access to. So, before we even do that, I just want to make sure that I verify that we can access the CBT Nuggets webpage because, denying access to something you don't verify you have access to in the first place is never any good. So I'll do cbtnuggets.com, hit enter. It says transferring. Okay, sure enough, there is the CBT Nuggets webpage. Good. So we verified that we can access it. Now let's drop down to our router. And in this case, we're also going to be on router 2. Remember, denying with extended access list should be done as close to the source as possible. So we're going to be applying it on that same interface. Now, this brings me to one of the rules of access lists. The rules of access lists is 1 ACL per interface. Oh, sign off the end here. Per interface per direction. So, when we're saying I want to deny them from accessing the CBT Nuggets webpage, we're going to have to tack on, to an existing access list that we already have there. Meaning we've applied access list 100, one access list, per interface to the fast Ethernet 0/0.10 interface. That's our per interface. Per direction, inbound. We've applied it inbound, and we're going to have that same policy. So what we're going to need to do is modify access list 100 to add this rule to it. So let's go ahead and go to router 2. I'm going to do a show run, include lines that have access list 100 in it. That'll filter my running output. All right, so there's my config. Good. So I'm going to copy. I'm going to do a copy. Open my ultra sophisticated notepad application and paste those lines in there. I'm going to back them up. Because what I'm going to do is I'm going to delete that access list, no access list 100, and recreate it. I'm going to show you a little more efficient way of doing this in just a moment, but for now, this is what we're going to do. I'm going to go in, and I see the IP address right up there. I'm going to say access list 100, deny, and then I'll come up and say, okay, what protocol? Now, whenever you're surfing the web, you're using the TCP protocol. So instead of IP, I'm going to put TCP. The source IP address will be the host 192.168.10.50. That's our host A. Question mark, and now it's asking for a port number. But remember, and I'll emphasize it again, if we put the port number right after the source host, you're going to be talking about the source port number rather than the destination. When we're surfing the web or doing most things, we're going to a destination port, and the source port is pretty random. So I'm going to go in, and I'm just going to keep going with the destination. Instead of saying any destination point, I don't want to deny the host from the whole internet. I just want to deny him from the CBT Nuggets webpage. So I'll say I want to deny him from the destination host. You can see that's an option, single destination host. And there's the IP address above the config, 128.242.116.211. So I'm denying them from accessing that specific host, which is the CBT Nuggets web server. Now, if I just hit enter there, I've denied too much. They will not be able to use any TCP application to access the CBT Nuggets web server. And in this case, it just said deny them from the home page, not all access. So I need to specify a port number. So I'm going to hit the question mark. You see there's plenty of options. I'm going to say equal to and specify the port number 80. Now, I want to mention that when I put equal to question mark, it puts a bunch of common port numbers that are right here. Well, somewhat common. It's been a long, long time since I've heard of the Gopher protocol. This is one of the original ones on the internet. That's not around anymore. But, you know, it does give you, for example, www shows HTTP port 80. So I have an option here. I can either type in equal to www, that's a valid keyword, or I could use the option at the top of this, and just put equal to and type in the port number, 80. I usually like using the port number rather than those keywords because I forget all the keywords. It's easier for me to remember the numbers of the protocols than all those names. So I type in equal to 80, enter. Good. I'm going to type in show access list 100, and let's take a look at it. Look at what the router did. It swapped out my 80 for www. It said, oh yeah, I'll show you. It knows what it is. It'll do that for you, and that's okay. So it says deny that host from accessing that host on equal to port 80 as the destination. Now we need to add a permit in there, and we also need to make sure our scenario 3 objectives are accomplished. So what I'm going to do is I'm going to go back to my notepad. I need to add that as my second line and that as my third. So let's copy that back to our clipboard. And in TerraTerm, which is what I'm using here, we can just right-click, and that will automatically paste. So I've pasted those back in there. I get rid of my notepad. And now, if I do a show access list 100, I can see line 10 or sequence 10 or first line is denying port 80, second line is denying the WAN link, and third line is permitting everything else. So let's test it. I'm going to go back to my web browser. Oh, wait a sec, not that one. Where am I? Here we go. Go back to my web browser, and you know what? I'm going to go in here and clear the cache. Oh, where's that? Do you know what I mean? The cache. How do you content? Block pop-up windows. Oh, what am I thinking? Maybe security. Passwords. Oh, come on. Privacy? Privacy. Oh, there we go. How about I do this? Always clear my private data when I close Firefox. I'll clear everything. The reason I'm doing this is because I want to make sure that when I close Firefox, web browsers cache web pages, meaning this will show up again next time without having to contact CBT Nuggets. I don't want it to do that. I want to make sure that it tries to contact CBT Nuggets and it says, you know, I'm going to clear it all now, wipe it out. Good. Wham, it's gone. Now when I open my Firefox, there we go. We've got the Firefox start page, and that's going to Google. So I know my Google access is working okay. Let's try another website first. I'll do www. See, when you want to think of a website, you never can. How about ciscoblog.com? And what's happening right now is we're kind of hung here. There we go. Cisco Blog. Cisco Blog has now come up, and we've got access there. And before I even go to CBT Nuggets, I'm going to hit the up arrow on here and see. Take a look. You see, we haven't had any matches here or here, but we've had 131 matches on the permit because this host has been surfing the web. It took 131 packets to generate the Cisco Blog and Google homepage. So now let's do the ultimate test. www.cbtnuggets.com. Look at, I don't know if, can you see it at the bottom? It says connecting to cbtnuggets.com. I'm waiting. And while we're waiting, let's go ahead and come back here, hit the up arrow, and do that show access list. Look at this. Look at that action. 9 matches have showed up on that statement. Let's go back. We're waiting, and the connection has timed out, taking too long to respond. Frankly, it's never going to be responding because it is being denied by this access list. It is no longer permitted. Excellent. Now that we've done that scenario 4, we can remove that access list and never attempt such a silly objective again. But that is using the access list to block web access. Good. So at this point, you should have a little better idea of how to work with standard and extended access lists. Just seeing those scenarios and putting them in place, seeing the general syntax of them. Practice makes perfect on those things. I would say practice with yourself, writing down, you know, this is something I need access to, and here's how I access it. I always recommend whenever anybody asks me, should I set up a lab at home to practice this stuff? I say, by all means, do it. Cisco gear has become so cheap nowadays. And when I say Cisco gear, I mean stuff you can get off of eBay for practice in your own home lab. You can get a Cisco router for under $30 nowadays that can route your home internet connection. And that will give you the opportunity to go in there and try this out. Come up with objectives of what you want to deny and practice using access lists because that's the only way that you'll be able to master those. Now, let me show you some cool tips and tricks of how to work with access lists. First things first, numbered access lists, like we've been using all along, have been enhanced in recent times by named access lists. Now, named access lists have been around for a long time, but they've only recently begun to become very popular, and I'll show you a couple features of them. Notice we've been typing in, as we've been typing our access list commands, access list, and we type in our number. But Cisco has a nice little thing that you can do. You can type in IP access list. Same command, but look at the difference. And now it comes up and says, would you like to create an extended, a standard access list, use resequencing features and some other things. But right here, we can create our IP extended or our standard access list. Same thing as the numbered, but now we can specify. Let's say I want to create a extended access list, since that's what we're talking about. Extended, and I can type in word, meaning name. The great thing about typing in a name is you can be very descriptive in that name of what the access list does. Instead of just thinking, oh yeah, access list 100, I think that's the one that denies host A, right? Well, we can type in as the name, deny host A. Nice and descriptive. Now when I hit enter, you notice it takes me into NACL mode. That stands for Named Access Control List. So I'm in NACL mode, and now I can start adding in my permit and deny statements. I can say permit, host 192.168.10.50. Same syntax as the numbered. It's just you don't have to type in access list 100 in front of everything. So permit that host to access the host. Well, I'm just giving some examples. Oh, you know what? I forgot the protocol. Permit the IP protocol, or TCP, or whatever you'd like to do. Permit I'll just put TCP as second, and permits for TCP to that host, and so on. We keep adding numbers, and now when I do a show IP access list, you can see that I have access list 100, and then I have access list deny host A. It's much more easy to remember that. Now, I will tell you, functionally, these are the same. They do, and they can accomplish the same exact things. It's just this one gives a nice name along with it. Now, only from the named access list mode can you edit access lists. And this is the big feature I want to show you. All along, we've seen this 10, 20, 30 next to things. 10, 20, 30. That is known as a sequence number. Only recently has Cisco been adding that feature to their access lists. And what that allows you to do is modify access lists after you create them. Before those sequence numbers came around, the only way to modify an access list was to do what I showed you before, copy it to Notepad, delete the whole thing, and then kind of modify it in Notepad and paste it all back in. It's kind of a pain. So what we can do with these sequence numbers is I can make modifications. You notice. Let me hit the question mark. From named access list mode, it shows I can type in permit, deny, or even type in a sequence number. So maybe I wanted to squeeze something in. Like, as you add, it just keeps adding to the bottom of this access list. But I wanted to squeeze something in between these two. So I could type in, before I did my permit command, sequence number 15. Permit, and then same thing. We'll say TCP from the host 192.168.10.50 to host 4.2.2.4. Now when I go back and do my show command, you notice, look at that. Nice. I know, if you haven't seen access lists before, it's kind of like, that's kind of cool. But I'm telling you, nice. That is such an improvement from what it used to be. And literally, you'd have to delete the whole thing and recreate it if you wanted to do something like that. So not only can we squeeze in, but we can remove. I can say, oh, well, you know what? Now that line 15 is in there, I don't want line 20. I can just type in no 20. No sequence number 20. And now when I go back, you can see sequence 20 has disappeared. Nice. It's great. So we can modify these, and even nowadays we can even modify our numbered access list. But the way we do it is by, let me stop using the up arrow. I type in IP access list extended, but instead of typing in a name, I can just say 100. And now I can make changes, and I could say no, or NOST, no 20 on my access list 100. And when I do the show access list now, you can see line 20 has been removed. Pretty cool. So that is our way of modifying access lists using the named feature. Now, last but not least, what I would like to do is show you a reflexive access list. To review, what we talked about in the concepts video was maybe you wanted to create an access list that denied all internet traffic into your organization. It's a good policy because you don't want uninvited internet traffic to come on in. Well, if you create an access list that says deny IP any from the internet, you're going to deny everything, including stuff that your clients were trying to get. So when you try and surf the internet, when the response comes back, it will be denied. To fix that, you can use a reflexive access list, and let me show you how it works. I'm going to go on my router 2, and let's use a named access list since we've learned them. I'll type in IP, or actually this will be on router 1. Let me jump over there. On router 1, I'll type in IP access list, and we'll say it's extended. It must be an extended access list. And I'll say the name of that access list will be filter internet. See how these names can be real nice? IP access list extended filter internet. And under there, I can say permit TCP traffic from any source to any destination. I want to show you the keyword, established. That's it. That's a reflexive access list. Now when I come back, I can go under my, let's see, what's the internet connection? Ethernet 0/1. Can go under Ethernet 0/1 on router 1 and type in IP access group, filter internet, inbound. So what that does is under, let me jump back to the slide and diagram this out. Under Ethernet 0/1, as things are coming in, remember that direction, hold out your arms, in that interface from the internet, it will go against that access list. Now that access list says permit the TCP protocol from any source to any destination if it has been established. What established means is that there's been some request from the inside that has established a TCP session with a host out here on the internet. Once the host from the inside has established that, this host may come back in on that same response or for that same session and reply. That is known as established. If somebody else out here, will say this host, tries to come into the network, but there was no established, then it's going to come to this line, and the first line says permit anything that's been established, and it'll say, oh, sorry, you don't match because you're not established. And then the last line of that access list says deny IP any. Remember the invisible implicit deny? So it will be automatically denied since it's not an already established connection. So that is using what's known as a reflexive access list to heavily filter your internet connection. Whew, I would say that is one of the most action-packed, dense videos I have ever recorded for CBT Nuggets. There's more information in that video than I think I've packed into anything else. What I would recommend is extended access lists. While going through that and setting them up, it seems it makes logical, it makes sense. It takes a while for it to soak in. So what I would say is it'd be good for you to try a few of these. Put up some objectives for yourself and write out what you think would be a good access list to test that. I've been asked before, should I set up a home lab for the CCNA if I'm studying for that? And I say, if you can, by all means, do it. You can get a Cisco router, it's pretty good off of eBay for less than $30 nowadays. They've dropped in price for some of the older ones. And that's all you need to practice this. And that's, I would say, a great way to get some experience with extended access lists. All right. So what we did was kind of wrap up everything, went through all of the standard and set up some standard access lists and the extended, and we expanded on that looking at the named access list, editing access list, and reflexive access lists. Last thing I'll mention before we get into the next videos, which are going to be on NAT, I did set up internet access through router 1 for this video, which means I set up NAT on router 1 so that the host could access the internet, so we could do some cool demonstrations on blocking access. I am going to turn that off before we get into the next videos, which is all about how to turn that back on, because it seems kind of silly to get into NAT when you're thinking, but I thought you already